And now for your learning enjoyment, I will try to do all of the exercises on this page. This is page 345. Let's look at the first one. The first one says, the domain of a sequence is the set of consecutive blank numbers. Well, if we look back here, it says a sequence is simply a list of numbers, yada yada about the numbers, and then it says a sequence is a function whose domain is a set of positive integers. But we've already seen a bunch of sequences that are in fact containing fractions and negative integers. So I think that this book right now has, if we put it on the crapometer, it is moving slowly this way because the answer key says that it's a set of consecutive natural numbers and nobody knows what that means. Secondly, a sequence with a last term, it must end somewhere, therefore it's finite. But if there's no last term, it must not end anywhere, and therefore it's infinite. The sequence that looks like this is what kind of a sequence? Well, this is this kind of sequence here. It's a sequence, it gives it as an equals 2an minus 1. So you can see that n appears here and it also appears here. In other words, the definition resides within itself. In order to find out, for instance, A25, we'd have to go to A24, and we wouldn't know what A24 was unless we figured out 2A23. So you can see that this information goes back this way, and we can't figure out A23 without going to A22, and so on and so on and so on and so on. It goes until we get down to A1, and it tells us what A1 is. It tells us that A1 is 2. So all this business of going back and back and back and back on itself is called recursion, and that makes this a recursive sequence. So this is a recursive sequence. The formula for the nth term of an arithmetic sequence is, arithmetic sequence, we'll remember, arithmetic sequence, nth term is, and this is worth writing down, it's worth remembering, equal to A1, or the first, sometimes they just call it A and not A1, plus n minus 1 times d, and d is the distance between each of the terms in the sequence. And n minus 1, of course, if it's the 10th one, you'll, like if it's the 10th term, then this will be 9 times the distance added to the first one. Okay, so an arithmetic sequence is always that way, and we'll use that formula actually in some future, well, not on this video, but on the next video. Write the first 4 terms of each sequence. The first 4 terms of each sequence. Let's get us a piece of paper. What we'll do is we'll say the first 4 terms, so we'll go 1, 2, 3, 4. I'm just going to make a table like that. And that way we can just put some of these in here. So n squared minus 2. So the first one is n squared minus 2. So 1 squared minus 2 is negative 1. 2 squared minus 2 is 2. 3 squared minus 2 is 7. 4 squared minus 2 is 14. So that's the first one, and there's the first 4 terms of the sequence. Let's skip ahead here. Let's do this one here, which is a little bit more complicated. It says 3 to the n over 2 to the n plus 1. That's a lot more complicated, but if we sub a 1 in there, 3 to the first power is 3 over 2 plus 1, so that's 3 over 3, and that equals 1. 2, so 3 squared is 9 over 2 squared plus 1, so that's 9 over 4 plus 1, so that's 9 over 5. And the third one is 3 to the third power, which is 27. 2 to the third power is 8, plus 1 is 9, so 27 over 9 is 3. And 4, 3 to the fourth power is 81, 2 to the fourth power is 16, so plus 1 is 17, and that would be 81 over 17. I don't think that simplifies at all. So that's a complicated one. I'm not going to do any more, but you get the picture. Where there's an n there, you just sub in the appropriate value for n. And these were all the n's. So making the table is the easiest way to do it. So, number 3, let's get another piece of paper for number 3. Number 3 says, write the nth term of the suggested pattern. Well, let's look at the first one here. We don't have to write anything down. You can see that it's 1, and there's a 2, there's a 3, there's a 4. So, the nth term here, you can see that it's 1 over n, because where n is 1 is the first term, 1 over 1 is 1. Where n is 2, it's 1 over 2. Where it's the third term, it's 1 over 3. The fourth term is 1 over 4. The nth term will be 1 over n. That was easy. Let's do this one here. Let's not do that one there. That one's really complicated. Let's do this one here. 2 over 3, 4 over 9, 8 over 27, 16 over 81. You might notice that that's 2 to the first power, 2 squared, 2 cubed, 2 to the fourth power. 3 to the first, 3 squared, 3 to the third, 3 to the fourth power. So what we've got here is 2 to the third to the nth power. That's the first term, so that's 2 thirds to the first power. That's 2 thirds squared. That's 2 thirds to the third power. So this one, the nth term would be 2 over 3 to the nth. Now let's look at a couple of examples for this last one here. Write the first 4 terms of the recursive sequence. What a pain. We'll just do the first one. They're all pretty much similar, but we'll write this one out on a big piece of paper. Let's see if we can take that one on. So, the first one said a equals 4, so the first term of the recursive sequence is 4. And then it says, comma, t n equals 2 plus t to the n minus 1. So it starts at 4. The first 4 terms of the sequence, I know the first term is 4, and there's going to be 4 more terms. 1, 2, 3, second, third, and fourth term, dot, dot, dot. So we have to fill in the values here. So the first term is 4. The second term, T2, is going to be 2 plus T n minus 1, or T1. Now T1 we know is 4, so it's 2 plus 4, so T2 is 6. T3 equals 2 plus T2. And minus 1 here is 2 because this is for T3. So T2 was 6, so 2 plus 6, and that equals 8. So that's 8. T4 equals 2 plus T3. We're rolling right along here. T3 was 8, so that equals 10. And those are the first 4 values of that recursive sequence.